In this, we are going to talk about the second question on LeetCode. Add two numbers, and which is asked by company like Amazon, Facebook, and many more. I'm just name a few here, and let let us read the question statement. So, add two numbers. You are given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order, and each of their nodes contain a single digit, and the two numbers return the sum of the linked list. You may assume the two numbers not contain a leading zero. We don't need that. So let us understand it a better way with the example. So these are the two given linked list we have, 243 and 564. So these are the reverse order. So actual number would be like 3. Actually take it as a 9, so it would be a good example. 3 4 2 and like 9 6 5 7 0 13. Yeah, 3 13, and yeah, you got it. This is the answer, and they want return linked list something like that. 7031. This will be our result linked list they wanted. You got the question, right? So now let us understand how we are going to solve this kind of question. So first of all, there are no brute force approach or something like that. There's only one optimal solution you can have for this kind of question. And also in the question that is clearly mentioned that the each node has only one single digit, means it can max to max have 9, not 10. Did you get the point? Yeah, let's jump into the solution. And so first of all, let me take a bigger example so you can understand it better way. 3 2 1, it's going to take 9, and yeah, 8 4 4 7 3. Yeah, this is our this is basically null. So yeah, whenever you have a question related to linked list and something like that, let's first take a dummy node. And this dummy node basically return us the head of the linked list. Yes, I don't mention here that here we are going to just return the head of our linked list, and the head will actually connect to the whole linked list. So yeah, and this dummy will later return us actually the head we needed. So yeah, and also take a temp pointed to it, because we can't move the dummy node, we are just going to move the temp variable. So yeah, this is it, and take two pointer here, L1 and L2. Now also we have to like take two sum, two variables, and carry, C for carry. And so yeah, sum and carry. So if now we want to start iteration, in our first iteration we check that if L1 not points to null, add the L1 dot val to the sum, and sum is first of all is 0. Yeah, and also this one is also 0. So here we can clearly see that L1 not points to null, so L1 dot val would add to 3, and also L2 not points to, so it will like 7. Cool. So now we are going to create a new node which will be contained to 7. 7, and what we're going to do is connect this, as simple as that. Temp.next gonna be the new node we are going to create it, and the temp will point to the temp.next, so temp will come here. Now also each time we are going to move our L1 and L2 if they are not null by one step ahead. Now again, and sorry, and let's start our second iteration. And in second iteration we are gonna reinitialize our sum to 0 again, and check if L1 is not points to null at the value 2, and here we have 7, and also move them in the second iteration, so like 2 7 9. And also we have to see that if carry is not equals to 0, non-zero, also add the carry to the sum also. So since here carry which points to 0, initialize with 0, so right now we don't have to worry about that. Later we will gonna see how to do it. So now the 7 is points to 9, and it is legal, means we can store 9 max to max in a single node. So create a node for 9, and temp.next points to 9, and temp come to 9. As simple as that. Second iteration is finished. Now third iteration begins, and in third iteration we are going to have L1 points to 9, so 9 plus 3, and also we're going to move 1 ahead. So 9 and 3 12. Our new sum will be like 12. But do you think we are going to like create a new node of 12 and temp will point to temp.next will point to 12? No, we can't, because in the question we are clearly mentioned that we can only store a single digit in a node. So in that case, what we're going to do is like sum modulo 10, and in case of 12 it's gonna return us 2. So this will be our new node. Don't worry, I will. And our carry will be sum divided by 10, means 1. So now our carry is 1. Did you get the point why we do that? Because in the question it is mentioned that we can only have the single digit, otherwise we can put the 12 into a single node. Since we can't do that, that's why we did something like that. Sum modulo 10, which will be our new node, and in our carry we will carry the 1, sum divided by 10. Yeah. Now since L2 is null, we are not going to add anything to L2, but L1 is points to 8, so we are going to add 8. So sum is 8 right now, and L1 also moves our 1 ahead, and also carry had 1, so 8 plus 1 which is going to be 9, and it is perfectly fine to add 9 to a node. So 9, and our temp gonna be here. And since L1 also points to null, L2 also points to null, and our carry becomes 0, so we don't have anything, and we don't need any more iteration to perform. Yeah, that's it. And now this will point to null by default. Actually, we don't have to mention it. And from our result linked list, you can clearly see that our dummy.next will point to the new node head of the linked list. So this linked list we want to return as a result. I know this is a little complex to understand, but watch this video twice or thrice and you will get the gist of it. The intuition behind it is very simple. You just have to like add things. Yeah, as very simple as to be honest. And let's also discuss the time complexity about it. The time complexity would be how many iteration we are going to have basically. 1 2 3 4. We actually here we had like 4 iteration. So yeah, we can do something like that. Is O big of maximum of m into n, and here m is basically the number of elements or nodes we have in our first linked list, and n is number of elements we had in our second linked list. So you can see that here we have 4 iteration, and in the first linked list the largest one, and in the first linked list we have 4 elements, so we just actually did 4 iteration. So from that we can derive this formula. And about the space complexity is very simple. We go of m plus n. How much extra space we gonna require? We actually create a new linked list which will contain all the nodes of L1 and L2. So yeah, m plus n. Yeah, and this is the intuition, and let me show you the code also. So this is the actual code solution for the question we have discussed about right now. Add 2 numbers. So let us understand each line very clearly. So we are going to just create a function or method which will get 2 parameters, two head of the linked list, L1 and L2, and as we discussed, we are going to create a dummy node. You can see that, and a temp pointer which will point to the dummy node, and also carry is outside the while loop, means each iteration carry doesn't depend on the iteration. Carry is independent of iteration, that's why carry is outside of the while loop. And inside while loop we have the sum variable, because in each iteration some variable actually just only depends on each iteration, and at the beginning of each iteration the sum will point to 0 basically. Wow, okay, all right. And how many times or until what happening we're going to run the while loop? Until L1 doesn't equals to null, L2 doesn't, or L2 doesn't equals to null, or carry is non in 0, means like carry is equals to 1. So until then we are going to run our while loop. And now, as I told you before, while if L1 not equals to null, sum, add the L1 dot value to sum and move the L1 one node ahead, and same for the L2 too. And also add the carry. If carry has any value, doesn't have value, so it will be 0, and if it is have any value, add any value, so add it to the sum. And then add a new carry to it. So if it's less than 10, in the carry will always be like 0, because 9 divided by 10 doesn't make sense, it will be 0 point something. So, and since it is an integer value, it will only take the 0. Okay, and let's create the new node of our summation. Sum modulo 10 will be our new node value, and temp dot next will point to the new node we created here, and now temp will be move one step ahead and point to the actual new node, because yeah, that's it. And in the end of the while loop, after finished while loop is finished running, we're going to return just basically dummy dot next, and which will point to our new head. So that's it.